Hello and welcome back to Coffee with Enyx. On this new episode, episode 3, we will give you a demonstration of the Enyx Inspector. The Enyx Inspector is a tool that is provided with our FPGA development framework, which is very useful for the development and troubleshooting of hardware applications. But before we go over this, here is a quick summary of the previous episodes. On episode 2, we went over our end-to-end trading engine solution, Enyx Access, and how it helps our customers move their software trading logic into FPGA. The first episode was a deep dive into our FPGA development framework, nxFramework. And today's episode is going to be a continuation of this episode, so please make sure to check it out. The link is going to be below in the description. But just to make sure, here's a quick summary of what comes with the Enyx framework. The Enyx framework brings everything that an FPGA developer would need for neutral or latency projects. First, we include board support packages to be able to abstract the underlying hardware. Then we provide configuration files and scripts to help with the whole FPGA workflow from simulation to firmware generation. Then we include key connectivity IPs such as a TCP stack, a UDP stack, and a PCIe engine so you don't have to recode it. More recently, we added utility IPs to help with the processing that is needed in every project with streaming and memory buses, as well as basic mass function and key processing such as hash tables or CRC calculation. But as mentioned at the beginning, today's video is about the Enyx Inspector, which is a graphical tool, and Clément will give you a demonstration of that tool. So without further ado, Clément, please take it away.
Hello everyone, I'm Clément Boudier, Application Engineer for the Technology and Design Services branch at Enyx, and I'm going to show you in this video an example usage of the Enyx Inspector tool that is provided with the Enyx Development Framework. The Inspector is an Enyx tool designed to browse the hardware FPGA boards and inspect in real time the content of the firmwares currently loaded in the FPGA devices. A complete documentation is available to registered users on our website in the documentation section that lists all of the features available with this tool. This video will show a concrete example usage of the Enyx Inspector. Let's open a web browser and connect to the FPGA server where the FPGA boards are located and where the Enyx Inspector tool has been installed. As long as the Enyx Inspector tool is not started, the web browser will not show the content of the board. So let's go ahead and connect to the FPGA server to start the Enyx Inspector tool. The Enyx Inspector tool can be automatically started at power-up of the FPGA server as a service as explained in the documentation. Back to the web browser, we can see there are 3 FPGA boards with Enyx firmwares configured on the FPGA server, and the Enyx HFP driver is properly loaded, allowing us to see these 3 FPGA boards. Expanding one of the trees allows us to see the Enyx cores that are detected using MMIO inside the corresponding device. Each core can then be individually accessed, and the complete list of registers is exposed in several different categories that we can see here. The configurable data, which are the registers that can be both read and written. The monitorable data, which are the read-only registers. And also specific core commands that can be executed. Registers in the Enyx Inspector can be followed so that a visual diagram is presented showing the value of the corresponding registers through time, reads being performed each second. For demonstration, the uptime register in this specific core can be monitored by pressing the Follow button. If there are any paged registers, such as in the Enyx TCP stack, then these are also shown in individual paged sections of the web browser. Here we are inspecting an Enyx TCP stack that has 2 different paged sections of the registers. one for configuration of the virtual interfaces, and another for configuration and monitoring of each TCP session. We can also see specific commands, such as the TCP session commands, along with the required arguments to be set prior to these commands. The Enyx Inspector allows us to refresh and reset each individual core through the node data section, as well as perform raw read and write access to specific addresses of the core. Let's get started with the demonstration. We will be using the Enyx SmartNIC design from the Enyx development framework as an example. This design features an Enyx native interface, allowing the Enyx board to act as a standard network interface itself. It also features a full RTL ultra-low latency Enyx TCP stack, Enyx UDP stack, and Enyx 10GB MAC PCS IP cores. All of the user interfaces are connected to specific DMA channels for the software layer to send and receive raw TCP payloads, raw UDP payloads, or raw Ethernet payloads. These connections are done inside the sandbox where the user logic can be inserted, placed between all Enyx cores. This specific sandbox also features packet counter registers on each interface. To test connectivity, we will first use the Enyx native interface by configuring its IPv4 address and pinging this address from a remote server. Then we will enable an offloaded interface in the TCP stack and ping this new interface from the same remote server. We will finally configure and open an offloaded TCP session in the TCP stack and connect to this TCP session once again from the remote server. Let's start by pinging the remote server through this Enyx native interface. The FPGA server hosting the FPGA board has a network interface enabled since an Enyx native interface is enabled in the Enyx SmartNIC design. We can see this interface with the usual interface configuration commands, ifconfig, for example. On this FPGA server, the Enyx native interface is named FPB2IO. Let's configure the IP of this native interface. The pings will actually go through the FPGA, and we can monitor this through the Enyx Inspector. The corresponding physical interface is properly connected and has the link status up, as we can see in the corresponding Ethernet interface MMIO core. We will follow the packets going into this interface, then start the pings. We do see the packets going in due to the ping requests, but also going out in the TX instance due to the ping replies. The packets can also be seen directly in the Enyx User Sandbox SmartNIC core, since packet counter registers have been inserted for each interface in this core. Both around the raw interface, but also around the native interface. We will now manually configure, through the Enyx Inspector, an offloaded virtual interface in the TCP stack. Now that the virtual interface is configured, we can ping this new virtual interface. We can see the pings once again, and the packets going through the corresponding physical interface, which is the same as the netif on this design. However, now the pings are targeting the TCP stack, and therefore can be seen in the TCP core. Here we can see the packets in the TCP stack going in and out. As the last test, we will manually open a TCP session and connect to it using netcat. For this example, we will configure a TCP session as a server for the TCP state to be listening to a new client connection. We are choosing to configure TCP session 0, but we could have very well selected any other available session. Let's start by configuring the parameters used to open the session. We can see here we are selecting interface ID 0, which we previously configured. We can now see that the TCP session 0 is in a listen state. We can now connect to the TCP session using netcat from the remote server. Now that the client has established a connection, we can check on the Enyx Inspector that the TCP status has changed to established. Now TCP packets are sent out to the offloaded TCP stack, and we can see these packets in the TCP session packet counters. Thank you for your attention, and feel free to contact us if you have any questions.